Hello students, welcome to day 40 of 99% in 99 days in your class 10th board. So now we are going to start the last chapter of chemistry, that is carbon and its compound, okay? And in today's class we are going to revise about the covalent bond and homologous series, okay? We will discuss why carbon forms covalent bond, what are its special features that it has. So all these things will be covered, okay? So let's get started here. So first of all, why carbon has to form covalent bond? Why not ionic bond or any other type bond, right? So first of all, see, carbon, if you see the electronic configuration, carbon is having 4 electrons, right? The electronic in the valence shell, it has only 4 electrons. Now we know if it gains 4 electron, it will become 8, which is a stable noble gas configuration. Or if it loses these 4 electrons, then also it will get the stable configuration of helium, right? But this gaining of 4 electrons or losing of 4 electrons, both are difficult in case of carbon. Now the reason for that is, you can see, it may gain 4 electrons to form C4 minus ion, okay? But what is the problem in that? But in that case, it would be difficult for the nucleus with 6 protons to hold on to 10 electrons. Okay, so carbon has only, you can see carbon has only 6 protons, right? So carbon will have only 6 protons, okay, and outside it has 10 electrons, right? 10 electrons will be there. So now because of this 6 protons and 10 electrons, this bonding will be very, very difficult, okay? Next thing, why we can think, okay, second option is it can lose 4 electrons, okay? Just if we remove these 4 electrons, 2 electrons will be left, which is a stable noble gas configuration of helium, right? But here what happens, it could lose 4 electrons to form C4 plus cations, but in that case it would be required huge amount of energy which is not energetically favorable. So to remove 4 electrons, it is an endothermic process, right? We will require a huge amount of energy, right? So that is why carbon can neither gain 4 electrons nor it can lose 4 electrons. So that is why carbon cannot form ionic compounds, right? So what is the solution for that? Carbon overcomes this problem by forming covalent bond. And all of you know what is covalent bond? Bond formed by sharing of electrons, okay? Fine. Now coming to talking about why carbon can form covalent bond, okay? It can share, no doubt, that is correct, it can share 4 electrons, but it has 2 special properties because of which it can form a large number of covalent compounds, okay? So the point here is carbon, okay, carbon can form a huge number of covalent compounds. Okay, you can find different varieties of covalent compounds, right? The reason for that is these 2 reasons are there. The first is carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large number of molecules. This property is called as catenation. That means what? Carbon can form like this, you can see a long chain of carbon atoms can form bond. That is the first thing. Next, it can form double bond between 2 carbons. We can find triple bond between 2 carbons, okay? Such type of properties is not found in any other element. So that is why in the world or in the nature, you can find only carbon has so many compounds, okay? Next, since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element, okay? So carbon can form 4 bonds at a time because it is having 4 valence electrons, and it has this property of catenation. So these 2 properties helps the carbon to form a large number of compounds in this universe, okay? Fine. Okay, so students, here I want to draw your attention towards DSAT, okay, Diksha Scholastic Aptitude Test. Now, since you are in class 10th and after a few months your exams will be over, and now you will be at a point where you need to choose the right career for you. right? And this is a very big decision and should be taken under proper guidance. So that is why DSAT is there, where you will be given a 60-minute lecture and then you will be having one aptitude test. Now this aptitude test will be evaluated and you will get a one-on-one mentorship who will tell you about your weakness and strength and can tell you the right career choice for you. Okay, so if you want to be a part of this, do not delay, go to the description section, you can find the registration link and click on the link and register for DSAT as soon as possible so that you can choose the right career for you. Okay, let us continue with our lecture. So now covalent bond we understood. Covalent bond is by sharing of electrons. Now why carbon can form so many covalent bonds? Because of its catenation nature and because of its tetravalency, right? Now the covalent bonds are of three types: single covalent, double covalent and triple covalent. You can see single covalent, double covalent and triple covalent bonds are present. Okay, now we will see some example where the covalent bond is formed. Hydrogen molecule, if you see. Okay, so hydrogen has 1s1 and this hydrogen has 1s1, right? So okay, let me not write like this, this will confuse you. We will write this hydrogen has 1 electron, it has 1 electron, right? So we will get like this, 1 electron and 1 electron. Okay, this is what the covalent bond is present, and in covalent or in dot structure we represent electrons as dots. Okay, so this one will be represented like this. Next, O2. Oxygen, if you see the electronic configuration, it is 2 and 4, right? Next oxygen, you have 2, so sorry, 2 and 6. This electronic configuration is 2 and 6, right? So I'll draw one oxygen with 6 electrons, 1, 2, 3, 4 and 5, 6, and I'll draw another oxygen 1, 2, 3, 4 and 5, 6. Okay, so now what will happen? We'll get a bond like this and a bond like this. Okay, so you can see oxygen will form 2 bonds here, right? Next, if you see, okay, octet is satisfied, you can see 1, 2, 3, 4, 5, 6, 7, 8, and for this oxygen also 1, 2, 3, 4, 5, 6, 7, 8 satisfied. Okay. Next, if you have nitrogen, nitrogen electronic configuration is 2 and 5. So another nitrogen is also 2 and 5. So in the valence shell we have 5 electrons. So we can draw nitrogen like this. One nitrogen is like this, another nitrogen is like this, and let me draw this part little so that you can visualize it properly. Okay, this is 2 nitrogen. Now I have 2 electrons here and 5 electrons are there in the valence shell, right? 3 electrons I'll put here, right? So you can see 5 plus 5 is 10. So 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10. Nitrogen octet is satisfied, 6, 7, 8, and here also 6 and 7, 8. Okay, this is N2 and this is O2. Okay, and this is H. Clear? Now coming to CH4. So if you have carbon, carbon electronic configuration is 2. Okay, and just now we discussed that 2 and 4. Hydrogen electronic configuration is, it has only 1 electron in the valence shell. So there are 4 hydrogen, so we can draw like this. C is 1, then you have 4 hydrogen, 1, 2, 3 and 4. Okay, so we will have H, H, H and H, then carbon, 1 electron of carbon, 4 electrons of carbon, and then you will have 1 electron of hydrogen, right? So you can see this as a structure of CH4. Carbon octet is satisfied, 8 electrons are there, right? Okay. Next, coming to properties of covalent bonds, these are very important to identify the covalent compounds. First is it has very low melting point and boiling point. If you compare ionic compounds, their melting point and boiling point is very high. Okay, but in covalent compounds the melting point and boiling point is very low. Now what is the reason for that? You should know this. They have generally low melting point and boiling point because the force of attraction between the molecules is not very strong. Okay, the force of attraction between the molecules, like means suppose you have a CH4 molecule and you have another CH4 molecule, right? This is one molecule, this is another molecule. The force of attraction between the molecules is weak. Okay, so that is why you can easily boil them or melt them. So the boiling point and melting point is low. Okay. Next is they are poor conductors of electricity. This is also very important point. Now what happens in covalent compound, if you see this one, right? You see these electrons will be attracted by the nucleus of carbon, right, by the nucleus of hydrogen. So there are no free electrons. For conduction of electricity, always remember we need two things. Either we need free ions or we need free electrons. But in covalent compounds, these electrons are shared, right? It is shared between two elements, that is carbon and hydrogen. Means this electron pair is attracted by the nucleus of hydrogen as well as the nucleus of carbon. So these electrons are not available freely. Okay, so that is why, this is because the electrons are shared between atoms and no charged particles are formed in these compounds. Third is about the solubility in water. So covalent compounds are usually insoluble in water but are soluble in organic solvents like ether, chloroform, etc. Okay, so they are not soluble in water but they are soluble in other organic solvents. Okay, fine. Now coming to allotropes of carbon. So very important thing, what do you mean by allotropes of carbon? So now what happens, allotropes are the different forms of the same element having different physical properties. Okay, the element carbon occurs in various forms in the nature with different physical properties but nearly same chemical properties. Okay, so when a element in the environment occurs in different forms under different conditions, they are called as allotropes. Okay, they have different physical and generally they have different physical properties. Chemical properties is somewhat similar because they are all made up of the same element, right? So we have allotropes of carbon, diamond, graphite and fullerene. Okay, we'll see about them in detail. Coming to first is diamond. Okay, so diamond, it is a giant molecule of carbon atoms in which each carbon is bonded to 4 other carbon atoms, forming a rigid 3-dimensional structure which is responsible for its hardness. Now in metals and non-metals chapter, we have studied that the non-metals are generally soft, right, but diamond was an exception there, right? Diamond being a non-metal is the hardest known substance in the nature, right? Now what is the reason for that? That is the reason here is each carbon here forms 4 bonds with another carbon. Okay, so I'll show you the diagram, so I'll erase this. Now what are the properties of diamond? It is the hardest known substance. Okay, now it does not conduct electricity because there is no free electrons here. Okay, next it is colorless transparent substance. So you can see the bond of carbon here. Okay, you can see here, suppose you take this one carbon, right, it is connected to 4 other carbons, right? Now if you consider any other carbon, this one, it is connected to 4 other carbons. Now this carbon which is there, it is connected to 4 other carbons, right? So in this way the arrangement is made and the arrangement is very tight, so that is why the substance is very hard. Okay, next coming to graphite. Okay, so graphite crystal consists of a layer of carbon atoms in which each carbon atom is bonded to 3 other carbon atoms in the plane, giving a hexagonal array. So you can see what is saying, this is very important point. Each carbon atom, okay, is bonded to 3 other carbon atoms in the same plane, giving a hexagonal array. Now carbon has 4 valence electron, right? But in one plane, carbon forms bond with only 3 other carbon. So 1 electron of carbon is free here. Now this free electron which is present in the graphite is responsible for what graphite can conduct electricity. Okay. Now graphite structure is formed by hexagonal array being placed in layer one above the other. So you can see the diagram here. See, let me consider this one carbon molecule. Okay. Now you can see this is forming bond with 3 other carbon, right? You can see this one, if you extend one side, two side, and here this side, it will form another bond with another 1 carbon, right? So every carbon here forms bond with 3 other carbon only. You can see this one has 3 carbon, this one is forming bond with 3 carbon, this one will form, that side 1 carbon will be there. So in this way you can see that it is forming a hexagonal structure, and each carbon forms bond with 3 other carbons, and it has 1 free electron which is responsible for the conduction of electricity. Okay, so graphite is smooth and slippery in touch, okay, because you can see all the 4 bonds are not there, so the molecule is not very tight or hard as compared to the diamond. Okay, so it is smooth and it is slippery to touch. It is good conductor of electricity due to the presence of free electrons. Now it is greyish black opaque substance. Okay, now where it is used, the most widely used graphite is in the pencil slate, right? We use graphite there. Okay, so you can see that graphite you can easily what I can say, mash it, you can easily break it, right? So that is that much soft, and the softness of graphite is due to its structure like this. Okay, fine. Next, allotrope is called as fullerene. Okay, fullerene, it is the recently discovered allotropic form of carbon. The first known fullerene was known as carbon 60. Okay, so in fullerene what happens, the carbon atoms form bonds in such a way to form a spherical structure. Okay, so it was named Buckminster fullerene due to their resemblance in structure with the geodesic domes. Okay, these are some domes present, and the Buckminster, the fullerene that was designed C60, okay, it was used, or it structure resembled with the domes, so that is why the name given was here Buckminster fullerene. Now what are these uses of these fullerenes, why it is very, very important compound? So these fullerenes are generally used as carriers. Okay, suppose you want to transport some insoluble substance or some ionic substance, something. This substance which is to be transferred can be put inside this fullerenes and can be transferred. Okay, so imagine, like for example, in the body you want to put some drug. Okay, you want to give some drug, but that drug will be soluble in the blood, but we want to protect it from getting solubilized in the blood. So what we'll do, this you are seeing vacant, it is not vacant. Okay, it is completely filled. So inside this we can put the drug and then we can allow this to pass. So this is one example. Okay, just telling, there are many other uses, but yes, this is one example where the Buckminster fullerenes are used widely in organic chemistry. Okay, fine. Now coming to very, very important topic, that is homologous series. Now see, it is a series of compounds in which the member present have the same functional group and similar chemical properties, and any two successive members in a particular series differ in their molecular formula by a CH2 unit. Example series of alkenes, methane, ethane, propane, butane and so on is a homologous series. Now whenever we talk about the word series, okay, suppose we have been given with a number like 2, 4, 6, 8 blank, right? Can you guess this number and this number? Yes, you can see this is plus 2, this is plus 2, right? This is plus 2, and here if I add plus 2 I'll get 10, and then plus 2 you will get 12, right? So series means that there should be a common gap between the members of the series. Similarly, in homologous series, the gap, this difference between the two members is a CH2 group. Okay, now so what I can say is, so for example, I wrote one compound CH3OH. Okay, I want to write the next member of this series. The only thing I need to do is I need to add a CH2 group here. Okay, now if I want to write the next member, it is CH3, CH2, CH2OH, right? So this much was present, I just added one CH2 group. Next, if I want to write CH3, CH2, CH2 and another CH2OH, right? You are just adding one more CH2 group, right? So this type of series or this family is called as homologous series, okay, because they have the same functional group, okay, and the members of the homologous series should have what? Same, they have same chemical properties. I'll not say same, but you can say they have similar chemical properties. Okay, they have similar chemical properties, okay, but they have different physical properties, different physical properties. Okay, now what can be the reason for this? Why they have similar chemical properties but different physical properties? See, chemical properties depends on the functional group. Okay, so chemical properties depends on what? It depends on functional group. Okay, it depends on functional group. Now here we have all the members have the same functional group, OH, 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 right? So because the members have the same functional group, we can say that they have similar chemical properties, okay? But the physical properties generally depends on what? Mass. For example, boiling point, melting point, density, right? So these all things depends on the mass. And you can see as we go down the group, the mass is increasing. Here we had only 1 carbon, here we have 2 carbon, here we have 3 carbon, here we have 4 carbon. So as the number of carbon increases, the mass will increase, right? Now if the mass will increase, then the physical properties will be affected. So that is why homologous series have same physical properties, but different physical properties but same chemical properties. Okay, fine. Okay, now we will discuss some properties of this homologous series. Okay, so this can be asked in the exam, so you should know 2 to 3 properties of homologous series. The first one is they have the same general formula. Okay, so for example, I have a homologous series of this one, CH3OH, CH3, CH2OH, okay, then I have CH3, CH2, CH2OH, right? So what is a general formula for this one? I can write CN, okay, HN. So if you can see, if 1 carbon is there, then 4 hydrogens are there. If 2 carbons are there, then we have 6 hydrogens, right? If we have 3 carbons, then we have 3, 4, 5, 6, 7, 8 hydrogens, right? So what is the relation? You can see, for 1 carbon you have 4 hydrogens, for 2 carbons you have 3 plus 5 plus 1, 6 hydrogens, right? For 3 carbons you have 8 hydrogens, right? That means you have, like, if you increase the carbon by 1, the hydrogen increases by 2, right? That is there. CH2 group is there. So I can write CnHnO, right? So this can be a general formula for the, this can be a general, 3, 4, 5, 6, 7, 8, yes. So this can be a general formula for this type of homologous series, okay? So I will not write N, that may confuse you, okay? Let me take some other letter, X, okay? Clear? They have the same general formula. The successive members differ by a CH2 group. This I have already told you. Whenever you go to the next member, or if you want to find the previous member, you have to remove a CH2 group. If you want to find the next member, you have to add a CH2 group, right? So when the successive compounds differ by the CH2 units, we call it a homologous series. Now, what will be the difference in their masses? So now if you see, CH2 is 12, carbon is 12, one hydrogen is 1 gram, 1 AMU, another hydrogen is another AMU. So total 14 AMU. So I can say that the members, first member, second member, third member and fourth member, the difference in their masses will be 14 AMU, first and second 14, second and third 14, third and fourth 14, right? So that is what molecular mass difference is, 14U. Next, members of the homologous series show similar chemical properties. I already explained you why, because they have same functional group, okay? But here I want to add a point that they have similar chemical properties but different physical properties. Okay, clear? Okay, now coming to, okay, so here once again I have already told you about DSAT, so nothing much to explain here. But yes, if you want to choose a right career for you, if you want to know which is your strength, which is your weakness, because the stream that you choose in the next 2 years will be something which is going to decide your future, right? So this decision should be taken with very cautiously and under proper guidance. So if you want help with this, we have launched DSAT, where you will be getting a 60-minute lecture and then there will be a test based on the lecture that was done to you. And once you appear this test, the test will be evaluated and you will be having a one-on-one mentorship where you will be told about your strength and weakness and which career is suitable for you. Okay, you will be given guidance, and with that you can ask your doubts, you can ask your queries, and definitely this will help you to choose the best option for you. So if you are interested in this, do not delay. You can go to the description section, registration link is there, click on that and register for DSET as soon as possible. Okay, so thank you students. With this we are done with today's class, and in the next class we are going to discuss more about carbon and its compounds. So this series will continue for one more class, and then we will be solving the most previous year questions as well. Okay, so continue this series, and if you have liked this video, do not forget to subscribe the channel. Thank you for watching, and once again see you soon in the next class.